Hey everybody, so everything's going well. So for today's lesson, we're going to continue with transformations, okay? And this is actually going to be broken up into two parts, okay? So this is 8.3 part 1, and this is another type of transformation. And these are a little bit tricky, so I want you to pay attention. And as I always say in class, once you get it, it's really easy. That's the truth, okay? These are what we call rotations. Today is April 6th. Okay. So, first of all, what is a rotation? Well, a rotation is a transformation in which a figure is rotated about a fixed point. And for now, the only fixed point we're going to rotate around is the origin. Okay. So, I kind of want you to envision if you remember when we did translations, okay? If we did translations, when we looked at a graph, it was like we had a figure and then we slid it to somewhere else. So it looked like the exact same figure, okay? When we did um, reflections, okay, we had a figure that we reflected over an axis, okay? For example, the y-axis or the x-axis, okay? That was what reflections was, okay? Now, when we do rotations. Okay, these are, like I said, a little bit trickier. I almost want you to think of it like, let's say I've got a figure like this, and if I had a string that was connected right here to the origin, and let's say I had a tap, okay, and then basically I'm going to rotate this figure in a direction. And actually, we're not going to go in that direction, so disregard that. If we go in a counterclockwise direction, okay, we would expect this figure to look probably something like that. Or if I was to go 180 degrees, okay, and keep going this direction, okay, it might look, it's hard to draw. But let me just explain that that's what it I want you to envision like that. Like you've got a string connected to an object, okay? Now, when we do this, there are some rules that we're going to have to keep in mind, okay? Um, before we do that, let's go ahead and get to our objective. Okay, our objective for today, this is the first part of rotations. Okay, our objective is for students, they will understand how to rotate an object 90 degrees counterclockwise and 180 degrees about the origin. And again, the word about the origin, that basically means like we've got a string tied to the middle and we're going to rotate that thing. Okay? All right. Hopefully everybody's got that. Okay, so some of the rules. Okay, well, let's start with the 180 degree. 180 degree is really, really easy. Okay, if you are rotating a figure 180 degrees, okay, the rule is pretty simple. Okay, every point on a graph has an x value and a y value. Okay, and when you rotate it, this is the original. Okay, and the rotated point, okay, we're going to have an opposite x and an opposite y. What does that mean? Well, let's say that, for example, I have seen some points on x, on an original point. Let's say this was 3, 5 on the graph. Okay, if I rotate that exactly 180 degrees, all I'm going to do is make each coordinate opposite. So the opposite of 3, the new x is going to be -3, and the new 5 is going to be -5. Okay, does that make sense? Okay, so this would be the original x, y, and this would be the rotated x, y. And those would be my answers. Okay, let me explain it on a graph. It might be a little bit easier to understand. Rotating 180 degrees is really simple. Okay, let's say I've got a point. Let's say I got a triangle here. Okay, and let's just make this a real simple triangle like this. Okay, and again, I want to emphasize some of you guys still are not writing the coordinates. Okay, I don't want to take points off, but I'm going to have to because you're not writing the coordinates and following the directions. Okay, I need you to write the coordinates of everything that we're doing. Okay, so we're going to rotate this 180 degrees. Yeah, 180-degree rotation. So we're going to write the coordinates for A, write the coordinates for B, and write the coordinates for C. Okay, A is back 1 up 2, so -1, 2. B is back 1, 2, 3, 4, 5 up 2. And C is back 2 up 1. Okay, so those are our original points. Okay, so if we rotate 180 degrees, I don't even want you to have to try to count from the origin or anything like we did when we did a reflection or a translation. Okay, those were simple because you just had to count. This one, all I want you to do is just write the coordinates of the new points, okay, and then graph it. Because I have a rule to go by, and the rule is simply every single one of these is the opposite. Okay, so let's find the new coordinates for A, the new coordinates for B, and the new coordinates for C. Okay, so if I have opposites, -1 becomes what? 1, and the opposite of +2 becomes -2. Then the new B, the opposite of -5 is 5. The opposite of 2 is -2. C, the opposite of -2 is 2, and the opposite of 1 is -1. Now let's take these points and let's graph it. And it should look like, if this is 180 degrees, it's basically like turning it around, okay? But we're rotating around this origin. So it should look kind of like this is rotated over to here, okay? And let's see what that looks like. My new A is over 1, down 2. My new B is over 5, down 2. And my new C is over 2, down 1. Okay, and as you can see, when I put these lines together, I did exactly what I was supposed to, and I took this point, and remember, it's like I had a string connected to here, and I rotated it 180 degrees, okay? Think of it like this. This triangle on this, in quadrant 2, was pointing down. This triangle is pointing up, okay? It's just been rotated, okay? I really hope that makes sense. If you need to rewind this and watch it over and over again, please do so. Okay, the next one. This one is a little bit trickier. I need you to pay attention, okay? All right, so I'm going to clear all this off of here. And so when we have a rotation of 90 degrees counter, sorry, that's an in. Let me make that better. Counter clockwise. Okay, and basically counterclockwise. Think about this: a clock goes this way, right? So counterclockwise is going to be going this way. Okay, so first of all, just like when I had a 180-degree rotation, I have a rule. Okay, so this is my original. Okay, I've got an X and a Y. Okay, when I have a 90-degree counterclockwise rotation, I'm going to flip and make my Y becomes X and my X becomes the Y. But there's one additional piece. This one becomes an opposite. What the heck does that mean? Okay, let's look at this. If I have coordinates of 4, -3, okay, first of all, I'm going to flip this. So this y becomes my x value right here. So this goes first. But it is no longer the -3, it's going to be the opposite. So what's the opposite of -3? This is now going to be 3. And this 4 is now flipped to the x value. Okay, so it's my x value, and I'm going to flip it with what becomes my y value. So now I have a 4 here. Okay, again, looks tricky, but it's really not that bad. If I had another point, let's say I had 0, -2. Okay, first thing, if you want to do it this way, you can just flop them. Okay, think of flopping them. I'm going to have -2 and 0, and then I make this first one opposite. So since it's a -2, it becomes a +2. If that makes it easier, do it that way. All right, so let's say I've got another point of 3, -1. When I flip them, I'm now going to have -1, 3. I just put my x in place of the y and my y in place of the x, and whatever becomes my new x is going to be opposite. So this becomes a +1. Okay, does that make sense? All right, so let's now move over to the graph and see if we can apply this a little bit. Okay, let's say I got a triangle right here. We'll make it a right triangle. All right, so wow, that was really cozy straightening. Okay, sorry. All right, let's say this is x, y, z. And we're going to rotate this 90 degrees counterclockwise. Okay, so let's write the coordinates of these first points. I've got an x, I got a y, and I got a z. Okay, what are my coordinates for x? Over 2, up 2. What are my coordinates for y? Over 1, 2, 3, 4, 5, 6, 7, up 2. My coordinates for z are over 2, up 1, 2, 3, 4. Okay, we're good so far. Now, remember, we have to write the coordinates for every single one of these. So the first thing I'm going to do is I'm going to write the coordinates of my rotated point, and we're talking about 90 degrees counterclockwise. Okay, so the first thing we're going to do is we're going to flip all of them, and then if we need to make that first one opposite, the new x value is going to be opposite. So I have x rotated, y rotated, and z rotated. Okay, so let's take these two and flip them. Well, they're still 2, 2, aren't they? Okay, but the only thing we're going to do is we're going to make this first one opposite. Well, what's the opposite of 2? -2. Let's take y. So we're going to flip the 7, 2 and make it 2, 7, and we're going to make the first one opposite. Well, if this is 2, it's now going to be what? -2. Then we're going to take this z and we're going to flop them. So I have a 4, 2, and this 4 I'm going to make opposite, so it's going to be a -4, 2. Okay, guys, watch this over and over again if you need to. Okay, I know it's a little bit tricky, but really it's not that bad if you just go by the rule. Okay, let's graph these new points. So my new x is -2, 2. So back 2, down 2. So this is my new x. My new y is back 2. Whoop, I messed that up. I'm sorry, guys. Back 2, up 2. Sorry. Back 2, up 2. That's my new x. Okay. And then back 2, up 7. 1, 2, 3, 4, 5, 6, 7. So here is my new y. And then my new z is back 4. 1, 2, 3, 4, up 2. Okay, so this is my new z. And if I look, okay, think of this like this, guys. I have a string, and it's connected right here with a tack. And all I did was rotate this 90 degrees counterclockwise. And my new figure, that's exactly right. That's exactly what it's going to look like. Okay? Just go by the rule, and you should be okay. All right? Again, I can't emphasize this enough. If you need to watch the video again and again and again, rewind it, pause it, start it again, do so, okay, until you get this. This is really not that hard. Okay, just keep in mind if you need to go back and look at all these rules. Okay, remember, flop or flip, I guess, then make the first value opposite. Okay, so let's give us a random point. Let's say I've got 7, -5. Okay, if I'm going to rotate it 90 degrees counterclockwise, I'm going to flop them. So now I have -5, 7, and I'm going to make that first value opposite. So this -5 would become a positive. Okay, I think that's easy enough, guys. Um, I will attach your worksheet. I've only got like 4 or 5 problems on there, so um, please remember to write the coordinates. Okay, I can't emphasize that enough. All right, peeps. I hope you have a blessed day, and I will talk to you next time. See ya.